Alright everybody, welcome back. Welcome. Welcome. Hey everybody, welcome back. This is video number 2. I did promise I'm going to split these videos up so that you're not watching one video for 60 minutes. Okay, so this is the second video, and this one will cover most of the solving and the graphing. Alright, first example here, we have 2x minus 4 to the 6th power equals 64. So the first thing you want to do is take the 6th root, because that's the only way that we can get rid of that power. Remember, a power of 6, to get rid of it, you have to do a root of 6. Remember, and I think I told you this before, when you take an even root, that means when you draw your own even root, you have 2 answers. So the 6th root of 64 is, when you take the root, is not only going to be 2, but it's also going to be negative 2. So this type of question you're going to have to split into 2 problems. First one will be 2x minus 4 equals 2. And then the second problem will be 2x minus 4 equals negative 2. And then just simply solve for x. So you want to make sure that these are both correct by checking both answers. So first I'm going to check 3. So 2 times 3 is 6. 6 minus 4 is 2. And 2 to the 6 does equal 64. And then I'm going to check 1. Notice everything is still in parentheses. That's going to make a difference later. So 2, sorry, I almost had negative. Now notice I have parentheses here, so that's negative 2 to the 6th. And remember, negative 2 to the 6th power with parentheses will give you positive 64. If we didn't start off with parentheses, then it might be a different situation. So everything is all good. Alright, next one. Minus 7 minus 7. 2x to the 3/4 power equals 16. Before we even take the root of anything, I'm going to divide by 2. And now I have x to the 3/4 equals 8. Now remember earlier I told you the best way to get rid of a fractional exponent is to raise it to its reciprocal. So this is 3/4, I'm going to raise it to the 4/3. What I do on the left, I must do on the right. Rewrite this as a radical. Don't just put in your calculator. So this is the root, so it's the 3rd root of 8 to the 4th power. 3rd root of 8 is equal to 2, and 2 to the 4th is 16. Now, if you want to check that, we're going to do 2 times 16 to the 3/4 plus 7 equals 23. Never touch the right side of a check. So this is really the 4th root of 16 cubed plus 7. The 4th root of 16 is 2. And 2 cubed is 8. Two times 8 is 16. And 16 plus 7 is 23. So it checks out. Alright, next we have 2 times x plus 2 to the 1/3 power. First thing you do want to do is get rid of the 2, so we divide both sides by 2. And we're left with x plus 2 to the 1/3 equals -3. So you want to rewrite this as a root. So this is really the third root of x plus 2 equals -3. Remember, the only way to get rid of a root is to raise it to that power. Raising a power of 3 to a root of 3 eliminates everything, and you're left with x plus 2 equals -27. Minus 2 on both sides, x equals -29. Now you want to check it. So 2 times -29 plus 2 to the 1/3 should equal -6. 2 times -27 to the 1/3, that's really 2 times the cube root of -27. And that's really 2 times -3, which is -6, which is what we wanted to get all along. Okay, so it checks out. Remember, in a check, never touch the right side. Your goal is that your left side matches your right side. Alright, next one. They both have the 4th power. So to get rid of the 4th power on both, I'm going to raise them both to the 4th. So the 4th root goes away, and I'm left with 2x plus 1 equals x plus 6. Because I need balance on both sides, first thing I'm going to do is move my x over by subtracting. Remember, there's an imaginary 1 in front of that x, so 2x minus 1x is really 1x. Now to finish this off and have balance, I'm going to do minus 1. And I'm left with x equals 5. Now the only thing you want to do from this point is check it. And I have the 4th root of 11 equals the 4th root of 11. That's it. You don't have to do anything else because we don't know what the 4th root of 11 is. Alright, so that ends the solving portion. So remember, rewind and keep playing as you continue to try to understand it. Oh, wait, 2 more solving questions. So here we're going to do plus 6 first. And then you still want to have x by itself, so you divide by 4. Now remember, I told you the only way to get rid of a fractional exponent is to raise it to its reciprocal. So we're left with x equals 4 to the 3/2. Now remember, this in essence is an even root. Remember, even roots have 2 answers, plus or minus whatever. So this is going to be the square root of 4 cubed. So that's really going to be plus or minus 2 cubed, which means your answer is plus or minus 8. And this really represents 2 answers. A positive 8 and a negative 8. So you have to check both. Okay, so our first check will be 4 times 8 to the 2/3 minus 6 equals 10. So 4 times the cube root of 8 squared minus 6 equals 10. The cube root of 8 is 2. And you all know that 2 squared is 4. 4 times 4 is 16, so 10 equals 10. Remember, you have to follow PEMDAS, and PEMDAS says to do exponents first, then multiply, then subtract. Alright, you also have to check negative 8. So the cube root of negative 8 squared, that's really negative 2 squared. Notice my negative 2 is in parentheses, so negative 2 times negative 2 is positive 4. And this is 16 minus 6, so 10 equals 10. Alright, so both of them check out. Alright, I think this is the last solving problem. So here we have a 3 in the front. Let's get rid of that first. And we're left with x plus 2 to the 3/4 equals 8. Now remember, the best way to get rid of a fractional exponent is to raise it to the reciprocal. So that's 4/3. Not an even root, so you're only going to have one answer. So these cancel out. And x plus 2 equals the cube root of 8 to the 4th power. Well, the cube root of 8 to the 4th power is 2 to the 4th, and that's 16. So minus 2x equals 14. So once again, you do have to check all of your answers. So we have 3 times 14 plus 2 to the 3/4 equals 24. 3 times 16 to the 3/4 equals 24. Remember, don't touch this side. This is really the 4th root of 16 cubed. 4th root of 16 is 2, so that's 2 cubed. And that's 3 times 8. And we all know that 3 times 8 is 24. So it checks out. Yes, it's a lot of work. Yes, it's a lot of writing. Yes, yes, yes to all your complaints. But remember, you want to get the right answer. So sometimes in life we have to go through a lot of steps and go through a lot of processes to get to the right answer. Alright, so that ended the solving section. So now we have a word problem. Remember, your word problems have important information that you want to make sure that you focus on. So they say from 1940 to 1996, the age to which a newborn can expect to live can be modeled by this equation, where t is the number of years since 1940. So, what is the life expectancy of a person born in 1960? That's 20 years after 1940, which means that in this question, t equals 20. So all you're going to do is plug in 20 for t. Now when you put this in your calculator, make sure that only that piece is in the parentheses. So I'm just going to show you real quick how you would put it in your calculator, because I know you guys have a problem sometimes putting stuff correctly. So you're going to put 1.78. Remember, that is not a root. It's an actual number. Second, there's a square root. 20 minus 0.3, close the parentheses, and then plus 62.7. You just put it all in your calculator just like that. And press enter, and there it is, 70.600, which is approximately 70 years old. But I don't want you to drop the decimals because, you know, it's important that you leave the decimals there. So 70.600. Oh, you don't need the full decimals because 00 is 00, so it would just be 70.6, and that is the years old. Which makes sense because back in the day, the life expectancy was a lot shorter than it is now. So, what is the life expectancy of a person born in 1950? That's 50 years after 1940. So, you plug in 50 for t. and this one is 75.249. Okay, these word problems no one should get wrong. Seriously, no one should get them wrong because they're all just plugging things into your calculator. Alright, so that ends that word problem. Now we're going to go on to graphing and transformations. Alright, the first one is a square root. So remember your original square root graph is always 0, 0, 1, 1, 4, 2. And you want to plot that before you do anything. Because usually your graphs are being stemmed from the original. Okay, so that's the original. So now the new graph is 2 times x minus 3. I want to pick numbers to plug in here that would give me 0, 1, 4. So if I plug in 3, that'll give me 0. If I plug in 4, that'll give me 1. And if I plug in 7, that'll give me 4. Okay? So when I work it out, it's 2 times the square root of 3 minus 3. Wait, let me work it out in the bottom because I don't have room here. So 2 times 3 minus 3, that's equal to 2 times the square root of 0, which is 2 times 0, which is 0. Next one would be 2 times 4 minus 3. So that's 2 times the square root of 1, which is 2 times 1, which is 2. And the last one is 2 times 7 minus 3. 2 times the square root of 4, which is 2 times 2, which is 4. Okay, so now that I have these 3 points, I'm going to plot those. 1, 2, 3. So this, my starting point, is my vertex. And remember, your vertex comes from here as well. Opposite and same. So I go to 4, 2, which I already have here, and 7, 4. So my new graph looks like from the middle to here it moved right 3. So that's my first transformation. You could say moved or shifted right 3. And if you look in between these 2 points and then look in between these two, there's an obvious stretch. And that stretch is vertical. It looks like it doubled in its stretch. So we would say it's a vertical stretch. But you always write by a factor. And the factor comes from the front number, which is 2. Okay? So now the domain is, where did we start? We started at 3. And we went all the way to the right, which is infinity. The range, we started here at 0 and then went all the way up to infinity. So basically for domain and range, you're breaking up your vertex. Alright, that's number 35. Alright, 36. You know that you should memorize this one as well. It's only 5 numbers. It's -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So you always should plot your original before you do anything. Because you want to see, how does the graph change from my original? Alright, my new graph, we have to see what's going on with my new graph. So it looks like it's negative x plus 1 minus 2. So, alright, what number do I need to plug in here to get -8? That would be -9. What number do I need to plug in here to get -1? That would be -2. What number do I plug in here? So basically, I'm like subtracting 1 from most of these numbers. Okay, what number do I need to plug in here to get 1? That would be 0. And then what number do I need to plug in there? Be 7. So now I got to work it out, just like I did here. So negative cube root of negative 9 plus 1 and then minus 2. That's equal to cube root of negative 8, which is negative 2, minus 2, which is negative 4. I'm probably going to run out of room. Oops. I made a boo-boo. I forgot that there was a negative in the front of the problem. So we have negative cube root of negative 8 minus 2. So the cube root of negative 8 is negative 2. So negative of negative 2 minus 2. So that would be 2 minus 2, which is 0. Lots of negatives here to deal with. Okay, so oops. Making all kinds of boo-boos here. Bear with me. It's been a long day. Okay, so the first one is negative 9, 0. Okay, then we plug in negative cube root of negative 2 plus 1 minus 2. And that is negative cube root of negative 1 minus 2. That would be negative of negative 1 minus 2 is 1 minus 2, which is negative 1. A lot of this can be done in your calculator if you don't know how to do it by hand, but a lot of you don't have a calculator, that's why I'm showing you all of this work. Alright, negative 1 plus 1 minus 2. That's 0 minus 2. Of course, negative 0 is the same thing as 0, so 0 minus 2 is negative 2. Notice this kind of like a pattern. Alright, next number to plug in is 0. So negative cube root of 0 plus 1 minus 2. And that's negative cube root of 1 minus 2. So that's negative cube root of 1 is 1. Minus 2 is negative 3. Okay. Last but not least, negative cube root of 7 plus 1 minus 2. That's negative cube root of 8 minus 2. That's negative, and this whole thing is positive, so negative 2 minus 2 is negative 4. Whew. Alright, so now let's plot these. This goes to 7, 8, 9, negative 2, negative 1, negative 1, negative 2, 0, negative 3, and 7, negative 4. Okay, so you should notice that the vertex for this graph is always in the middle. So this is the vertex for the original. This is the vertex for the new graph. It's always the point that's right in the middle. And it's also these two numbers, opposite, same. So we have negative 1, negative 2 is that vertex. Now going from vertex to vertex, it looks like I shifted left 1 and down 2. But the graph also flipped because instead of starting down and ending up, it started up and ended down, so it flipped. We call that a reflection. And it reflected over the x-axis. Alright, so my domain, because of the double arrows, my domain is going to be negative infinity to infinity and negative infinity to infinity. Yes, a lot of work. Alright, the next one is a square root graph, so you know that you have to do your 0, 0, 1, 1, 4, 2. This is the nice short graph. Okay, remember that's your original graph. And then here, we're just going to plug in 0 in there, and we don't have to pick different numbers because it's only one number under the square root. That plus 1 is outside. So I can just plug in 0, 1, and 4. So the first one would be the square root of 0 plus 1, which is 0 plus 1, which is 1. Next one would be the square root of 1 plus 1, which is 1 plus 1 equals 2. And the last one is the square root of 4 plus 1, which is 2 plus 1 is 3. So now we just plot these points. Alright, so looking at my HK, I don't have anything inside, so it would just be 0. So my HK is 0, 1. It looks like the only thing my graph did was move up 1. It didn't do anything else. There's no stretches because these are the exact same distance. It didn't flip. So all it did is that it shifted up 1. Okay, my domain is my starting point, so it starts at 0 and goes all the way to the right to infinity. And the range starts at 1 and then it goes all the way up to infinity. Alright, I think this is the last graph. It's cubic. Here's the original numbers. I don't know why I keep putting 2 there. Okay, so I'm going to plot this real quick because it's always good to plot your originals, because you want to be able to see what's going on from original to new graph. Alright, the new graph has 2 things going on. We got to find numbers in here that will give us these 5 numbers and then multiply our answer by 3. So again, there's going to be a lot of work. So I need negative 8 in here. The only number I can plug in is negative 11. Negative 11 will be all the way over here. So we don't need negative 11 in our chart. So we can skip that. Now I need negative 1. Well, negative 4 plus 3 is negative 1. So I can use that. So 3 times the third root of negative 4 plus 3 equals 3 times the third root of negative 1, which is 3 times negative 1. So our first answer is negative 3. Alright, if I plug in negative 3, I'll get 0. So 3 times the cube root of negative 3 plus 3 equals 3 times the cube root of 0, which is 3 times 0, which is 0. Alright, for me to get 1, I'd have to plug in negative 2. So negative 3 times negative 2 plus 3 equals 3 times the cube root of 1 equals 3 times 1, which is 3. And the last one would be, for me to get 8, would be to plug in 5. So the cube root of 5 plus 3 equals 3 times the cube root of 8 equals 3 times 2, which is 6. Alright, so now I'm going to plug in these numbers. 11, remember, the first one would be all the way over here at a negative 11, and I don't have enough room for that. So I'm going to go to 4 and negative 3, negative 3 and 0, negative 2 and 3, and then 5 and 6. So these are the 3 that would be in the middle, like these 3. And then the other one would be at 11, which is somewhere over there. Alright, automatically I can tell that it is much more of a stretch. So here we have this little stretch, and then here we have this big stretch. So automatically I know that there's a stretch. It's a vertical stretch by a factor, and the factor that I choose would be up here of 3. Then I go from the middle, this is my vertex, and then I go to the vertex here, which is right there. So I move I move the right 3. So I'm going to say shifted, not right, left 3. Okay? And remember, if you study the things that I told you to write, you can just look here. Now the vertex, remember, comes from here, opposite, and second number stays the same, so my vertex is negative 3, 0. Double arrows tell me that my domain is negative infinity to infinity, and negative infinity to infinity. That was a lot. So, hope y'all got that. Alright. Next part is transformations from the parent. And you don't need to actually graph anything for this, thank God. So, you have to memorize this. Remember what each piece means. Okay, this is your vertical stretch and your vertical shrink, and also your reflection. I'm not going to go through the whole thing because you have this all written out in your notes, hopefully. Okay, and then this is your shift left or your shift right. Oops, I had it backwards. Doop doop. And then this is your shift up or your shift down. Alright, let's take a look at the first one. We have no vertical stretch and nothing being added on the inside and just this plus 2. So that means that we are just simply shifting up 2. Now the vertex is opposite of the inside. There's nothing on the inside, so it's 0. And second number stays the same. So your vertex is HK. Okay, opposite of that, second number stays the same. The domain always comes from the vertex for squares, and the range comes from the vertex for square roots, but since this is a cube root, it's all real numbers. So remember, for cube roots, it's always this. Alright, the next one is a cube root as well, and the same thing happens. Okay, it's basically the same answer, but instead of positive 2, it's negative 2. Which means that instead of shifting up, we shift down. Same domain and range. Okay, so remember, a cube root will always have domain and range of all real numbers. Okay, the next one is also a cube root, so before we even get started, I'm going to put those domain and range because I told you that. And that tells you it's a cube root. So then, because only something's going on the inside, that means that it's opposite of that. Second number stays the same. So my vertex is 2, 0. Always do the opposite of what's next to x, so I'm not moving left, I'm actually shifting to the right. Alright, the next one is a square root, so I need my vertex to do the domain and range. So it's opposite of this number, second number is 0. So the first number of your vertex goes for domain to infinity, and the second number of your vertex goes for range. Now there's nothing going on with this square root function except that opposite of that it moves to the left. Alright, so remember that for square roots the domain and range come from the vertex. Alright, here we go with that pesky negative here. So that's going to change one of our answers for the domain and the range. For the range, actually, not the domain. So, again, our vertex is at negative 1, 0. Again, we shift left 1, but we also have a reflection because of that negative. and that's a reflection over the x-axis. Now, the range, so the picture's actually going to look something like this, where the original looks like this. So here's your flip. So your domain is going to be the same from the first number of the vertex to infinity, because you're still going left to right, but the range will be different. The range actually is like pointing all the way down, so that means it's at negative infinity here, and then it stops up here at 0. But because you have to write things in order from smallest to biggest, we're going to say that this goes from negative infinity to 0. Remember, order matters, not the picture. You got to go from the order. Alright, next one, opposite of what's on the inside. Second number is the same, so it's 1, 0. That means that we're only shifting right 1. There's no negative, so we just use our vertex for the domain. 1 to infinity, and for the range as well, 0 to infinity. Alright, that was it with graphing and parent functions. So now we're almost done. 2 questions, and that's it for the review. Alright, so when rock climbing, you have this function here that they're using. And they said that t is the time in seconds and h is the height. So how long does it take for this stone to reach 20 feet high? So that means that t is the time and h is the height, so we're going to put 20 in for h. Now you know 100 minus 20 is 80. So put this in your calculator and then round it to 3 decimal places. And don't forget your unit. You guys love to forget your unit. Don't forget your unit. Alright, so it's 2.236 seconds. Alright, next one says how high is the stone? That means you're looking for h. How long meant you're looking for t. So we're looking for h here. So that means that 2 goes in for t, and we're looking for h. Now we've done these problems before. It's no different. We just haven't done them in a word problem. So here we have 1/4. I don't want a fraction, so I'm going to multiply by the reciprocal. Instead of raising it to the reciprocal, I'm just going to multiply the whole thing by the reciprocal. Okay, 4 times 2 is 8, and the 1/4 here drops out. Now I said we've done these problems before with problems, not word problems. So I want to get rid of this root. So the only way to get rid of the root is to square it. If I square the right, I got to square the left. So I'm left with 64 equals 100 minus h. I need balance. So that means I need to move all my numbers over. So minus 100. And don't forget that becomes a negative h. Now to get rid of that negative h, I divide by negative 1, and I find out that h is 36. And remember your unit, and the unit for that is feet. Okay, you never know, there might be one of these on the test, so I hope you pay attention. Alright, last question of the day. Here we go. The speed can be found by s equals 1.34 L. So that means that S is in knots, that's the unit, and L is the length in feet. So always write down the formula. And that's a script L. I know you guys aren't taught cursive anymore, but that's a script L. So they said, determine the length of a wave that is traveling at 3 knots. So 3 knots is S. So I'm going to plug in 3 right here. Do not put it here because you're trying to find L. Okay, so first thing I'm going to do is divide by 1.34 so I can get the square root by itself. And we got this real ugly decimal, long. And I don't want to, like, round this off just yet because if I round it, it might affect my final answer. So now to get rid of that root, you square it, because remember, squaring gets rid of the root. And you wind up getting 5.012 feet. Don't forget your unit. Alright, the next one says the speed of the wave. That means we're trying to find S. Okay? So S equals 1.34 times the square root of L. I'm going to plug in 9 because that's what they told me the length is. And I get 4.02 knots. Don't forget your unit. Alright, your secret message is going to you're going to have to do some research, and everybody always likes to do the secret message. So last night we had the Grammys, and in the Grammys we had certain things that occurred. Now if you don't really care about music or the Grammys, just use this wonderful tool that they created. It's called Google or even Wikipedia. So you have to answer these 2 secret message questions at the top of your paper. And you can find this information from Google, and you know what? You might learn something. Alright, number 1. Who was honored with the Lifetime Achievement Award? Okay, someone was given the Lifetime Achievement Award. Who was that? And the second question is, what were the awards won by Adele? Now, Adele won a lot of awards last night, so I want to know what were all the awards. There were about 4, I think she got. So Google it. Put those at the top of your paper, and I will give you credit for homework, because that means you actually watched the end of the second video, because the first video doesn't have a secret message. So good luck, and I told you this would be ready by 4:30, and it's 4:08, so I'm going to put it up on YouTube now. So good luck. I hope somebody watches it, somebody learns something from this, and I really hope that everybody passes. Alright, thank you. Bye.